Awesome. So all pretty much everybody except for one person has taken the test from Friday. As soon as I can touch base with that student, I will release the answers. So I hope to have the answers to the test released by sometime today. You guys did pretty darn good on it as a collective group. So I'm not expecting any shock about any of that, but just so you guys kind of know, I'd like to get you guys some feedback on that. So hopefully you have that back to you soon. So let's take a look at what we're doing now. So you have a big old honkin' packet in front of you. This big old honkin' packet is going to take you pretty much to the end of the semester. Let's talk about it. So we will not have semester exams as you normally would have them, right? You're not gonna have a double period where, half the time are here. And we're not even gonna have a carved out necessarily exam schedule. However, being an upper kind of more serious honors chemistry class, I don't think that we can go without having any sort of assessment at all. So what we're going to do the last week before winter break, we are going to do some form of review and then some sort of assessment. Whether that review packet turns into you can use that on the assessment or anything like that, I just can't. We also would end in the middle of a unit, which we don't want to do as well. And so we also want to just do some sort of review from the semester and some sort of assessment for you guys. So you can expect that the week before winter break. So this packet that I just gave you takes us all the way basically there. So if you still have all your old packets, make sure you're keeping those, all that kind of good stuff. The periodic table that you guys just received, you guys will need this for the entire rest of the year. This is the building blocks of stoichiometry. These are the things you have to understand in order to be successful in March. Okay, so we really want to make sure if you take a look at your periodic table and turn it over, you can kind of see where we're going to go. We have a lot of information already filled in. So kind of up until this point is the stuff in the first box at the top. You have your matter conversions, if you would like. You have some density stuff. Density of water is on there. Then you have all your thermochemistry stuff. You have Q's equal to MC delta T, your fusion, your vaporization. So all that's in your 4.18 is all on there. Okay. So that is your kind of reference sheet on the back. You can see we're going to get into stoichiometry. We have 3 definitions of the mole. We're going to do the gas laws. You have Kelvin's atmospheres at the bottom. We'll talk about polyatomic ions. We'll talk about prefixes and more covalently bonding. So by the time you are done with this periodic table, we are going to color it. You're going to write all over it. It's going to have a ton of information on it. You'll add other things to it that you'll need. But this will be a very important piece of reference material for you. So do make sure you hold on to this. Okay, if you ever rip it, tear it, want a new one, I can give you a new one, but you don't want to lose this guy. This guy is important. And we're going to start labeling it today. Today, we're going to start making it official. So that's kind of where we're headed with that business. Kind of a rundown of everything. And you can see here in our Schoology kind of where we're headed. That gel spaces. You don't want that. This one, boop. Okay. We are down here in atoms, and this test is going to take us all the way until this unit is going to take us to the 11th. I guess the last thing we should speak about is next week is completely remote. Everybody is remote. I talked to the cohort B people about this on Friday. I will have 2 lectures normally because that's a Monday, Tuesday. However, I will not be having anybody calling in. What I will do is I will go back to making lecture videos and lecture questions. They will be up the 23rd, and they'll have them both up on the 23rd. You can watch them both on the 23rd. You can watch one each day. You can watch them whenever. You just need to have these watched before we come back to school on the 30th. Okay? So at your leisure, whenever you want to watch them during that week. Does that make sense? Okay? So it's kind of a little scheduling stuff I like to go over in the Monday lecture. All right. So atomic structure. Let's do it. The thing about atomic structure is that sometimes students have had some atomic structure. Some students haven't. Some have a misconception. Like, oh, dude, I totally know that neutrons are negative. Like, I get it. Like, that's not what, no, they're not. But Okay, so we're going to spend the first couple minutes here getting on the same page, and we're going to do a little bit of math here to figure out what's going on inside of some of these atoms. Atomic structure also involves the history of the atom, which, albeit interesting to me, might not be interesting to everybody, but you kind of just got to learn some of this stuff. So here we go, atomic structure. So in your notes, wherever you're keeping your notes, if you would get a fresh sheet on your notes here, let's label it up. Unit 4, atomic structure. Unit 4, atomic structure. Unit 4, atomic structure. All right, so I'm sure that everybody's heard of these words somewhere in the scientific career. We're going to talk about the 3 subatomic particles. Sub means smaller than an atom. Particles. Up until now, we've been saying that atoms are indivisible. They're the smallest form of matter. That still stands. You can just take them a little bit further apart. But once you take them apart, they're no longer matter. We're subatomic. So there are 3 of them. Protons, neutrons, and electrons. Again, I think you've probably heard of some of those terms, at least in some form or fashion. Protons, neutrons, and electrons. And we're going to talk about the charge, the mass, and the location of each of these. Protons have a positive charge. You will see me draw them like a little plus inside of a circle. Protons have a positive charge. Okay, now this idea of AMU, oh, this should be covered up. This idea of an AMU is called atomic mass units, but I really don't think you ever need to know that. These numbers are always going to be like 45, 12, whatever. Okay, but we're using whole numbers here. But if you care, the proton has a mass of 1. Students often ask 1 what? It's called an atomic mass unit. That is like the tiniest way to measure something. So I don't really care about the AMU units, but write it formally in your notes so you know it. Okay. The protons, also about them, they are found inside the nucleus. The nucleus being the centermost point of the atom, which holds all the mass and a positive charge. Okay. Neutrons are actually neutral in charge. You will see me draw those with just an empty circle, nothing in them. Neutrons have a neutral charge. Everybody wants to say negative, but that's reserved for the electrons. It also has 1 atomic mass unit. It has a mass of 1, if I ask you, 1. And the neutrons are also located in the nucleus. Perfect. And then you got your good old electrons, last little guys around here. Electrons are negative. Electrons are negative. The actual mass of an electron, that you also don't need to write down, is 0.00054 AMU, which is, I mean, incredible. Like it's infinitesimal to us. So we're going to say the mass of an electron is nothing. Okay. You must know that in order for it to be a part of matter, it has to have a little bit of mass. So you have to know that. But in our relative understanding, electrons are so small that they have no mass. So a mass of 1, a mass of 1, and a mass of none is the easy answer. And your electrons are found outside of the nucleus. And usually people bring to the table a Bohr understanding of the atom, which is fantastic. So let's draw it, kind of what you probably are walking into with today. You have a nucleus. You have positive protons in the nucleus. You have neutral neutrons in the nucleus. And then hopefully flying around somewhere around the outside. Oh, and I'm sorry. You will write electrons as a little E, baby E with a negative sign next to it. Okay, so those are the symbols you're going to be looking for. If I'm abbreviating, I'll use those symbols for those particular subatomic particles. Hopefully this seems familiar to you. You're like, yes, this, I got it. Awesome. Pump it up a notch. Why don't you? Let's do that. All right, so the first thing I want to do is I want to skip this kind of page, and I want you to put your periodic table in front of you. Usually, we spend a day after the test where I make you guys play little games with the periodic table, write down a list of the elements you have to memorize, stuff like that. So we are skipping that. We're like pushing it back a little bit. So it might take you a moment to start to learn some of these symbols, but some of these symbols you have to memorize. If I ask you for chlorine and you're looking at C, that's carbon. You can't, so make sure you're kind of looking through these, studying these a little bit. So what you're looking at in the top, the center here, let's label this up. The H on all of them, you see H, N, P, A, S, G, E. That is the symbol. So I would just label this directly on your periodic table. That is called the chemical symbol. And obviously underneath that is the elemental name. So some of these you just have to know. Some of them are common sense, like O is oxygen and C is carbon. Some of them are harder, like Na is sodium, Fe is iron. And those are usually based on their Latin names. All right, so the first thing we're going to lecture about here, off your periodic table and into your notes, let's go. With the number at the top of every single box is called the atomic number. The atomic number. The atomic number. Okay, we're going to come back to that periodic table, slide it to the side real fast. Let's write atomic number in our notes and get some information about what the atomic number tells us. All right, so you will see the periodic table is actually a very beautiful, our next unit is just all about the periodic table. It's a beautiful feat of human understanding. It is actually set up so it goes up in increasing atomic number. What's the atomic number for hydrogen is 1, helium is 2, lithium, beryllium 3. It goes up and up. So if you're looking for a large number, you're going to look at the bottom. If you're looking for a small atomic number, you're going to look at the top. Okay. The atomic number tells the number of positive protons in any given atom. Tells the number of positive protons in any given atom. If you have learned about this stuff, you might not have learned about the international symbols. The international symbol for atomic number is Z. Don't ask me why, but Z is apparently what they picked. So when we do our full atomic symbol at the end, Z is always atomic number. Okay. The atomic number, okay, it's arranged by increasing atomic number. The biggest thing I want you to write down is that the atomic number never changes. If you change the atomic number, you have now changed what you have. So lithium is always going to have 3 protons. I don't care. It's like its social security number. Okay, oxygen always has 8. You cannot change that. That is by definition what that element is. It has to have that many protons in order to be that element. So let's take a look around the periodic table. Oxygen, I just gave away, has 8 protons. Can anybody find chlorine for me? How many protons does chlorine have? Number on top of Cl, he's all the way over to the right. You got it. 17. So you can tell me that. Or you can identify the element based off of his number of protons. What element am I talking about if I tell you it has 3 protons? Lithium. What about if you have 20 protons? Calcium. Okay, so its identity, it will never change. So going back to that periodic table, let's go ahead and write a little note to ourselves that says atomic number, number of protons at the top. Atomic number, number of protons. Awesome. The little number at the bottom. Oh, and if you want to write, do I have that up here? I might. Z? Yeah. Go ahead and write to yourself that that's Z. Awesome. Now we have this number on the bottom. This number is your atomic mass. let's write that next in our notes. Let's find out a little bit about that, and then we'll come back and continue to label our periodic table. Atomic mass number. Atomic mass number. Atomic mass number. All right. The atomic mass number is a little bit longer. You can probably paraphrase it. It is the number of protons and neutrons for one single atom. So remember, we talked about this already. The only things that have mass are the protons and the neutrons. So the atomic mass number is the sum of the only things that have mass anyways. So going back to that, the total number of protons plus neutrons for a single atom. Protons plus neutrons for a single atom. The symbol that you will see internationally for that is an A. Again, not really quite sure why, but that's just what you've used. A, I guess, more I understand for atomic mass. If you want to write that information here, protons and neutrons, and it's an A, that will help you in your studying, on your quizzes, things like that. I normally do let students use their own periodic table on their quizzes. So you want to make sure you have this written down. Awesome. Let's talk a little bit more about the atomic mass, then shall we practice it a little bit. So it basically tells you what's in the nucleus. And so don't write this down. Let's just do it. Let's pretend I was asking you about magnesium. Can everybody find magnesium? If you look at him, he is on number 12. Okay. So let's talk about how we can find some information. The Z, the atomic number for magnesium, is 12. But what is its mass? Now look at the number actually on the periodic table. It says 24.3050. Here is a note of how we're going to use this in our class. In our class, we're going to round to whole numbers. Okay, so what would be the atomic mass of magnesium? 24. There is one that I like to point out that gives everybody grief, so let's all just agree with it right now. Can you guys find chlorine way over on the right-hand side? Cl. If you look at that, it's actually 35.4527. And people are like, well, the 5 should round the 4, and then the 4 should round the 5. We're not going to do that. Put a little box. We will always use chlorine as 35. So just so there's no, if you want to match my key, okay, chlorine will always be 35. So put a little guy around here. I realize that the 4 should be rounded by the 5 behind it, and maybe we're not going to split hairs like that. I also am in line with the AP chemistry teacher. He always uses the mass of chlorine as 35 as well. So then other ones are obvious. Nitrogen is 14.0. Oxygen is 15.99. So that's going to go up. One's going to go down. Okay. So last thing here that we got to talk about, we talk about atomic mass, is what if I want to know the number of neutrons? What would you do? If there are 12 protons and 24 protons plus neutrons, what do you do to figure out how many neutrons there are? You're going to subtract. Okay, so don't write this part down. I'll give you the rule here in a second. What you guys just did in your head said, hey, protons and neutrons, that's just protons. If you do A minus Z, so if you want to write this, A minus Z always gives you the number of neutrons. A minus Z gives you the number of neutrons. Okay. So if you look at krypton, he's a noble gas. He's all the way over on the right-hand side, little Kr. Please note I did not say kryptonite. That is not a real thing. Okay, that is a comic book thing. Krypton, though, is a gas. He has an atomic number of 36, an atomic mass of 84. And that's what's being given. So Z is always the number of protons, and you can just be watching, no worries here. And if you wanted the number of neutrons, though, you need to subtract, and that would give you the number. Okay. Then the other thing you might need to do, okay, is potassium, same thing, 19 protons. Let's say you had an atomic mass, though, of 40 on this one. You would then know, okay, that your neutrons have to be 21. So sometimes it's because of these isotopes, you have to use the given information. Don't only pull information off the periodic table, and this will make more sense in a second. But if you've been given a mass, you have to use that mass, even if it's different than the one on the periodic table. Okay? If you find no other mass, then you take the one off the periodic table. Awesome. Here we go. We got to talk about ions, isotopes, and atoms. Isotopes. This is probably the toughest thing because you always have to have it in a pair. Isotopes are two or more of the same element, but they have a different atomic mass. Now, if they're the same element, they can't have a different number of protons. So that means they just have to have a different number of neutrons instead. Neutrons are those neutral particles in your nucleus. They just make you a little more weighty. They don't add anything except for weight or mass. Okay, and then it's always two that have to be compared. You can't just say, oh, that's an isotope. Like, of what? It has to be, those two hydrogens are isotopes of each other. You always have to have them in sets of two. Because on your periodic table, you will see, you're like, well, wait a second, brain busters. If protons have a mass of 1 and neutrons have a mass of 1, how are we getting all of these numbers with decimals? What's going on there? And the reason why is because there are lots of atoms that can have different number of neutrons. And so this is an average on here. And I don't think you have to write that. The periodic table has an average mass on there. Okay. Every single there is no correct mass. On here is just the most likely mass for you to find, but that's not the correct mass. Every atom is an isotope because there's no correct mass. Okay. Perfect. So if we were to take a look at that, the average chlorine, which we see on here, has an atomic mass of 35 and 17 protons. So that means the average would have protons of 17 and neutrons of 18. However, chlorine can also come as a persuasion, which has a mass of 37. You may never change the protons, so those have to stay the same. So these are isotopes of each other because they're the same element, just one has 18 neutrons and the other one has 20. That's it, just a little heavier. This is chlorine after Thanksgiving dinner, okay? Just a little heavier. So those are isotopes of each other. Awesome. One more thing, and then we'll turn you out to do a little practice, and I'll stop yabbing my gums. Atoms. Let's just jump right into that. Everything off the periodic table is considered an atom. People really hate that atoms have an actual definition and that they're not everything because everybody wants everything to be an atom, but here we are to ruin your life because it's chemistry. Atoms specifically have to have a neutral charge. Atoms have to have a neutral or zero charge. In order to not be an ion, if you are an atom, you have to have a neutral or zero charge. Now, we're going to go back real fast up to the top of your paper. Oopsies. So we were talking about mass, which includes the protons and the neutrons, but does not include the electrons because they didn't have any mass. Now we're going to talk about charge. The only two things that have charge are electrons and protons. So now we're not talking about neutrons at all. We're talking about positive protons and negative electrons. Okay, so that's where got to keep your mind right here. All right. So in order to be neutral, your protons equal your electrons. Your protons must equal your electrons. Okay. So if I were to draw a good old little carbon here, he has 6 protons, so I'm going to give him 1. Come here. 1, 2, 3, 4, 5, 6. So right now he's positive 6. In order to be neutral, he would need 1, 2, 3, 4, 5, 6. So if he has 6 protons and 6 electrons, he is an atom because everything's canceled itself out. Okay? I only belabor this because of the next thing we're going to do. Let's talk about ions. Last thing, ions. If it does not have a neutral charge, that means it is an ion because an ion is a charged particle. An ion is a charged particle. Okay. Looking back at my carbon right here, right now it's neutrally charged because every positive has a negative. What if this carbon, though, were to pick up an extra negative E? Now, totally, I have 6 plus, 7 minus. What is the charge of this carbon would be negative by 1, correct? Now I have a question. Okay. How in the world can I then get positive? Because can I add a positive proton to that? That's no longer carbon. Let's see. That's now nitrogen. So, man, can't I? Whoa, go away. I can't. Oh, okay. Can't add a proton. So instead of adding a proton, what you need to do is you need to say, hey, I'm instead, if I lose an electron, now I have 6 positive, but only 5 negative. That's how you get to be positive, okay? You may never add a proton. You can only take away electrons if you want to become positive, okay? Big idea. Where did that go? All right, negative ion has gained electrons. A negative ion has gained electrons. He's run around and stolen them from somebody. So you have more negatives because remember, electrons are negative and protons are positive. One of the technical terms you'll hear for a negative ion is called an anion. An anion, like an anode, is the negative one. Woo! Time to wake up. Well, that might be on. That might be down there. Then a positive ion, like we just said, you have to have lost electrons. You may not gain protons. The only thing you can do is lose negatives, less negatives. Has lost electrons. Awesome. And the name for a positive is a cation. Don't call it a cation, even though I can understand that. And the way that I remember it is a Ca. There's a giant positive sign right in the middle. A cation. One of my most embarrassing times here at Westerville North, I had a student come in and be like, oh, because like cats are positive pets, you know? And I'm like, what? Like, I'm a dog person. No. And they're like, well, no, I was taught that one time. And I'm like, that's silly. Who would teach like cats are positive pets? That's how you remember that cations are positive. And it's Miss Cochran across the hall. She teaches that. That was making fun. But, you know, however you remember it, whether you see that there's a plus sign right in the middle of cation, or you think you love cats, so they're the positive ones, whatever, cations are positive ions because they have lost electrons. So let's give an example here of that. Let's do this one. Lithium itself usually has 3 pluses. 1, 2, 3. To become an atom, he must also have 3 negative electrons. 2, 3. If you want to be lithium plus 1, all you have to do is lose an electron, and now I'm positive by 1. You want to be lithium plus 2, you have to lose another electron. You want to be impossible lithium plus 3, there you go. Okay, so it's all about gaining and losing electrons. That's it. All right, so before we turn you out, you got to do one more thing that I'm sure nobody has heard of before. It's called the full atomic symbol. So just write X in your notes. This is just a placeholder. There is no X on the periodic table. So I use that as the placeholder. So in a full atomic symbol, you write the symbol nice and big in the middle. The symbol nice and big in the middle. As a superscript in the front, you write the A. Does anybody remember which one that is? Atomic mass. It's different than the periodic table, so that's why being all wonky and hard there. As a subscript at the very front, you write the Z or the atomic number. And then as a superscript at the end, you write the charge. So what you might see is oxygen 16, 8, -2. So that's an example of how you will see it. This is called the full atomic symbol. It gives you all the information that you need about a particular atom or ion. If you ever, and I don't think you have to write it. Oh, here's some more examples here. Apparently I wrote for you. Hydrogen would be 1, 1, and then 0. Fluorine might look like this. It just gives you information. Not that you have to write this, but if you ever see just a symbol and a charge, like hydrogen +1, or sodium +1, or chlorine -1, that's called the ionic symbol. So whenever you're writing the charge, you write it up and behind it. If you're writing your isotopic symbol, you would see like carbon 16 instead of carbon 14, or oxygen 20. That number is up into the front by itself. So those are just some things you will see. All right, so now you have a worksheet. Let's put it in front of you. Let's see if you can't review. You can write all that, I'm sure. Let me help you kind of set this up. Now, a hint to you. A lot of people hate it, but I think it's important. This kind of heading here is always going to change. Always. Or else I just give people who are like, I just subtract column 1 and column 2, and that gives me column 3. And then I don't know what that means, but then I put it into column 5. So the columns at the top are going to change on purpose to make you actually learn stuff here. So let's set this up. Your Z, if you want to circle it here, is always your number of protons. So if you have Z as 55, your number of protons is going to be 55. The other thing you might want to write up here to help you get started is Z plus A. Z plus A is your, minus, what am I doing? Z minus, excuse me, A is always going to give you number of your neutrons, okay? So 133 minus 55 is going to give me 78. Now, let's talk electrons. This is told you right now in here that this is a +1 charge. So that means I have 1 extra proton. So if I am 55 plus, how many do I minus in order to end up with a +1? 54. So the number of electrons you have is simply 54. I have to have 1 extra positive. Then the full atomic symbol, I'm going to put my CS, cesium right in the middle. I'm going to put the charge up here. I'm going to put its A on top and the Z on the bottom. All right. Bi. It has a neutral charge on the next one. I don't see an A, but you know what I have? I have a periodic table. Can anybody find Bi on there? He is way down on the bottom right. 83. Thank you. 83. And so as soon as I know that, I then can move my protons. I didn't realize what time it is. And then you can fill in as we go along here. Awesome, awesome. Okay, let's take a break so I can show you one down here really fast. The nice thing about the way they set up the full atomic symbol and why I think they do, the number on the bottom is always your number of protons. So this is 11. Your electrons, if I have 11 pluses, How many minuses do I want to have? 1 extra plus. How many electrons can I have? I can have 10. Because again, if you're like, how is she doing that? Plus, minus. And I need it to end up to be that number once they've been combined. And then neutrons are super simple when it's set up in the full atomic symbol because this is mass at the top. This is atomic number. All you have to do is it's like a subtraction. 23 minus 11 is 12. Okay, so you have about 5 minutes remaining. If you want to open up and get your lecture questions going, or if you want to do this, we are going to do an activity that kind of uses this information. This is what your quiz is on Friday. It's all about, can you calculate protons, neutrons, electrons? So if it seems a little overwhelming right now, that is fine. We will get you guys there, okay? But I would hit those lecture questions, and then for homework, and the key is in the Wednesday folder. Oh, it's not Wednesday. The key is in the Monday folder. I would work on this tonight, okay? I'm going to come around to see if there's any questions out there. Then I'm going to come and bother and see who is here online.